In this video, we're going to learn how to solve problems involving linear magnification for your JAMB Physics. We are going to practice with 3 repeated questions for this subtopic, a reflection of light. So let's get started. The first one I have here says the magnification of an object 2 cm tall when placed 10 cm in front of a plane mirror is what? So guys, for this particular question, you don't basically need to solve anything. All you need to know is the fact that the magnification of an object in a plane mirror is always 1. So the correct option in this question is option D, which is 1. Alright, you don't need to solve anything. So that's it for this question. The next repeated question is this question. It says an image in a convex lens is upright magnified 3 times. If the focal length of the lens is 15 cm, what is the object distance? Okay, now for the basic formula for calculating object distance or image distance when focal length is involved, we have the basic formula to be 1 over f equals 1 over v plus 1 over u, where our u is the object distance, our v is the image distance, and the f is the focal length. Alright, so in this question, we have the focal length f to be 15 cm. Now, they are dealing with magnification. So the image distance v will be, they say the image in a convex lens is upright magnified 3 times. So it will be, let's call it 3. So it will be 3u. Alright, now because this is convex lens, an image formed in a convex lens is inverted. Alright, so this is going to have a negative sign. Okay, because we are dealing with convex lens, so that's why we're going to have this negative sign attached because of the inversion. Now, with these parameters we have, we can now plug it into, let's plug this parameter into this formula. This is going to give us 1 over, our focal length is 15, equals 1 over our image distance is minus 3u, okay, plus 1 over u. We are looking for the u, which is unknown, which is the object distance. Okay, so let's continue. Alright, so solving further, this will cross over the equality sign and it will change to a positive sign. So we have 1 over 15 plus 1 over 3u equals 1 over u. So when you find the LCM, LCM is 30u. Alright, so 15 into 30u, we are going to have 2u. So 2u times 1, we have 2u plus 3u into 30u, you are going to have 10. 10 times 1, you have 10, equals u into 30, you're going to have 30. 30 times 1, you have 30. So you make u the solid formula. This 10 goes over the equality sign and you change negative. So 30 minus 10 will give you 20. So you are left with 2u equals 20. So divide both sides by 2. So our u will be 10 cm. Okay, so the correct option in this question is what? Option A, 10 cm. Alright, so that's it for this question. Let's wipe this now and solve the last repeated question before we call it a class. Let's wipe this. Alright, so the last repeated question with this question, it says, which of the following expressions gives the linear magnification produced by a concave mirror of radius of curvature if u and v are the object and image distances respectively? So these are the options we have. Now take note of this particular question, guys. From these options we have, when you find the expression, you're going to arrive at this option C. We have it to be 2v, that's 2 times the image distance over the radius of curvature minus 1. So that's option C. That's the correct expression for this question. That's it for this video. Let's call it a video, guys. Hope you found it interesting. If you are new to our channel, ensure that you subscribe to this channel for more of our videos. Also like, share, and comment on this video. Tell me how you feel for what I learned from this video. If you seem to have any specific question to ask regarding what I've talked about in this video, feel free to leave your question at the comment section below, and I'll ensure to give you a response. Also, ensure that you're part of our channel membership, where you'll be receiving special information that will help to simplify academic work. So click on the join button to become part of the channel membership, and you'll be glad you did. Alright, click on the next one above, and I'll see you in the next video. Thanks for watching.